Our last example is going to be a trig example because what is life without trig? It wouldn't be any fun. So I'm going to start by breaking the fraction. Remember, you can break fractions into smaller fractions as long as you only break by the pluses and minuses in the numerator. And so as long as you leave your denominator intact, you're fine. So I have the limit as x goes to infinity of x over x minus the limit as x goes to infinity of cosine x over x. Okay, so taking the first one, simplifying it, we know that that becomes 1. And so when I take the limit as x goes to infinity of 1, then that answer is 1 because the limit of any constant as x approaches anything is the constant. Now, the second one, I'm going to have 1 minus something. So looking at cosine x over x, I want to lead you back to the squeeze theorem that you learned in chapter 1. We know that cosine x fluctuates between a max of 1 and a minimum of -1. Therefore, we know that if we're multiplying this times 1 over x, then we know that our limit of cosine x is going to fluctuate between -1 over x and +1 over x. Okay, so now I take the limit of each of the sides. So I want to know the limit as x approaches infinity of -1 over x and the limit of x approaching infinity of +1 over x, because if those limits are the same, then cosine will be forced to also be the same. So the limit of a constant over a variable, remember, that's the rule of either the limit property that you learned in this section, or you can use your horizontal asymptote rules where n is less than m. When n is less than m, the answer is 0. The same thing for the +1 over x, then it is also 0 because it's the same property. Therefore, that means if cosine is between these two, then the limit as x goes to infinity of cosine x must also be 0. So this entire relationship is 0. So I have 1 minus 0 as my answer, and my final answer, 1. The limit answer is 1. Okay, now I want to just extend it a little bit. What if, because you're going to have one of these in your homework, what if on that same idea I had the cosine of 3x over x? Do you remember doing a substitution saying if I could make theta match the value on the bottom, that I can use the same rules that I used before? So if I say theta equals 3x, I just need to put a 3 over 3 to make it balance, right? So I can put the 3 on the numerator outside, the limit as x approaches infinity of cosine theta over theta, using the same idea that we used with our 1 over x. It's identical. We know that this part is 0. The constant just stays, and 3 times 0, 0. See how simple that is? So make a note of that. Remember it. You're going to have it in homework.